Hello, ladies and gentlemen. Don't be shy. Please feel free to come and make your way to the front of the stage and join us for one of the final. Is it the final?
Yes, it is.
It's the final panel. Please do come and join us. We've got lots more energy to give you as we get underway with our next conversation. My name is Jane Witherspoon. I'm the Bureau Chief for Euronews in the Middle East. It's my pleasure to be here today talking about Is the Future of Connectivity Written in the Stars? So I'm delighted to introduce you to Dr. Maha Achour, founder and CEO of Metawave Corporation. Next to her, Abel Avellan, founder, chairman and CEO of AST, I should say.
It's SpaceMobile.
Play SpaceMobile, yes, SpaceMobile. And on the end, last but not least, Max Gulde, CEO of constellr. So we're going to get down to business straight away, Maha. And I think what we have to talk about at the beginning of this is Starlink. You know, Elon Musk, how are orbit satellites, becoming more and more critical?
Sure. Can we stand up? I like it better if I stand up.
You absolutely
okay,
take
good.
to the stage.
Oh, yeah, okay, good. So, Starlink. We all heard about Elon Musk constellation of almost 5,000 satellites launched. And he has full monopoly of that low orbit satellite constellation. The impact is huge because he can provide connectivity to remote areas for $100 and also can control wars. If you haven't heard that he provided connectivity to Ukraine during the war, and the day he stopped that connectivity, the war was impacted. So it tells you how powerful are these low orbit satellites, not only to monitor the sustainability of our global Earth, but also on the security that impact humanity.
Yeah. Max, have you got anything to add into that? I mean, I wanted to talk to you about the rapid commercialization of space, disrupting, connecting industries worldwide. What emerging capabilities, falling costs, new motivations, are driving this?
Yeah. Okay, so first of all, happy to be here. A few thoughts to share. So I think what we're seeing is we need to address some of the largest challenges in our world. And if I say world, this gives you an idea of the scale, right? And all these things, be it then solutions driven by AI and so on, they all will rely on data. And this data will broadly come from two aspects. It's, on the one hand side, it's global data on the physical reality of our planet. This could be anything from images to physical measurements as we would provide them on temperature, water, carbon, looking at the core cycles of what determines our planet. On the other hand, this data obviously needs to be delivered somewhere in order to make use out of it. And that is the connectivity side, right? So connecting basically the points. So now looking at the space sector over the last 10 years, maybe 15 years, what we're seeing is suddenly we're going away from government-led very large missions to access to space, which suddenly only is a few thousand euro or a few thousand dollar per kilogram anymore, which means that a lot more players can basically test things. So I think we can surely state, and the trend is going to continue, is that space was never closer than now.
Absolutely. Abel, nice to have you here. I know you've traveled far and wide to join us. Satellite-enabled connectivity could transform industries, supply chain, energy, and transportation. What use cases do you think will have the greatest economic and social impact?
Well, I'm a great believer that connectivity is a human right. Being able to access knowledge and information is a human right.
Yeah.
And there is 2.6 billion people that do not have access to broadband connectivity.
Yeah.
And in their phone. And I think space, it is positioned as the focus of our company, basically disrupting that and really making the difference in connecting the unconnected. So if you ask me what is the most societal change that space can bring is connecting the unconnected, making those 2.6 billion people that are not connected to the internet, connecting them to the internet in the easiest, lowest cost possible. And that's our mission, that's what we're doing.
In terms of the social impact and democratizing access to information? We're talking millions of people here. Can you tell me about the role that you think Saudi will play into this in the future?
Yeah, I think the kingdom had a, first of all, it's a large market. It's the largest market in the GCC. So it's 40 million people with a vast territory where this service is needed here. But also we think, regulatory speaking, the regulator here is very advanced. It's very advanced, in some aspects, more advanced than our regulator in the United States.
Yeah.
So it started to take critical and a pivotal and leadership role in the region and in the world, frankly, or how to really be a presence in terms of regulatory regimes on how to solve the humongous problem of the unconnected.
LEO satellites are expanding the internet globally. How can leaders ensure affordable, equitable connectivity reaches, remote and underserved communities? Maha, I think you'll probably have a few insights on this.
Sure. So as you know, that like what Abel said, democratizing connectivity is critical for various applications, from farming to education to sustainability. And as a physicist myself, you need to have a very large constellation of LEOs, right? Because these are not a geostationary satellites. And that's why Elon Musk is launching thousands of them across the globe and having control over it, right? Just this morning, Israel asked him to provide coverage in Israel for the war. So just to tell you, LEO is a very challenging constellation that you have to deploy. But once it's deployed correctly, and I hope Elon Musk, down in his heart, he has some good intention, because he's also offering it for free in Africa, for example, for now. But what I really want to also emphasize is that before you go to the LEO, you have the drones, right? Yeah. The drones are accessible to everybody. They're used to everybody, right? You can create a small constellation of drones that can provide instant connectivity for disaster areas, can provide instant imaging of farmland, of any areas that is needed. And drones are now very affordable. And actually, I almost going to sit soon on the board of a very high-performance drone company that can carry eventually up to 300 kilograms of payload, right? So you can put LiDAR, you can put cameras, you can put any kind of modules on it and run any application and collect data.
And this can be used, you're talking about this being used across industry.
Yes, absolutely. We don't need, with that, before you get to the LEO application, you can use the constellation of the drones. And every country, every industry can have the right to do that, for sure.
With the rapid commercialization of space, disrupting industries worldwide, Max, I'm going to throw this to you. What emerging capabilities and falling costs are driving this unprecedented momentum? We talked backstage about, optimizing water productivity, for instance. I know this is something you're very passionate about.
Yeah, so let's happy to share a few ideas here. And happy to give you a very concrete use case. And you see how the LEO capabilities on the one hand side in Earth observation, on the other hand in connectivity, are actually playing together to create real value on the ground. A few just to frame, because we've just touched drones, and we had a quick discussion about Africa. Give you a few numbers. So today, about 60% of all arable land is in Africa, which means I'm looking at 10 billion people in 2050, looking at an increase in water demand by about 50% by 2030. Africa is going to play a central role in global food security. Right now, yields, however, on average in Africa are really, really low. Drones could be one part of the solution. Usually they're too expensive for a lot of the smallholding farmers in Africa. So what you could be doing is using a connection of Earth observation satellites in LEO, and then on top of that, connectivity in LEO, to actually provide services and insights. And to make this very, very easy, is what you need to do is you need to record actual information about water use and water need for any field on the globe. And any field in Africa is obviously then included, right? And you can do that using thermal sensing And satellites are basically shot up every moment now, and we're doing the same, right? So provide you an accurate measurement of how much water is needed, how much water is used. And this is the, let's say, for example, for irrigation, but also for crop health assessment, this is the basis. Now this information will need to be ending up at the smallholder farmers. So you need connectivity, right? And this connectivity can be provided by a solution, Abel, as you are providing, to get the information to that person, to actually do the thing which needs to be done on the ground. Smart irrigation on the hand side, but it could be proper timing, calendars basically, for fertilization, for nutrition management, and all these things. And there's a massive leverage you can use looking at just the pure scale of what satellites are able to do. However, this then needs to be transformed. The data needs to be transformed in insights. And this is where AI is coming into play. And I'm sorry for, let's say, using this term maybe too often, right? But you can train models to actually take this, look at the global, I mean, you need the data to make global models and then apply to individual farmlands. And then you can tell them exactly how to best manage a single field. And that's true for every single field on the globe. You don't need the agronomists anymore. You just need AI models, basically based on good data. And then you have created a value chain from going from space, recording things, making sure these things are actually arriving where they need to arrive, and then creating the insights with the technologies we have today to basically solve the food challenge of tomorrow.
Maha, we were talking earlier and you told me that from your 3 days of listening to conversations, there are 2 questions about AI that keep coming up that people can't answer. Number 1, why it works. Number 2, this confusion between AI and ML, machine learning. Do you want to just expand on that?
So I'm a theoretical physicist, applied mathematician, so I do understand modeling. That was my PhD at MIT in string theory. And I understand all these neural nets, all of these graph theories that they are building. If you ask OpenAI CEO why it works, he won't be able to answer. I asked this question to every single AI presenter. No one can answer that. Expected. If Galileo and Newton had supercomputers back then and tested the drops of the feather, the rock, whatever, to understand the gravity, do you think they would have extracted the equation for gravity? Maybe not. So it's good that we have that path of machine learning. People confuse. I just listened to so many AI presentations. No one mentioned the word machine learning or ML. Everything they were talking about is ML, machine learning, which is training the algorithm based on synthetic or real data. These are not predictable. These are not forward-looking algorithms. As soon as you answer the word why, in my opinion, you can create true AI that is independent of synthetic data, independent of training data, which means risk-free. And that's basically my passion that I do on this side with the London Institute of Applied Mathematics, as well as some group in the Bay Area.
Anything you want to add? I mean, I wanted to move it on actually to Abel and ask you, as connectivity and networks expand into space, we have to bring in the issue of cybersecurity and how that is going to evolve. What are the new risks and what are the vulnerabilities that we're going to be facing?
Well, yes. I mean, when you solve big problems, that comes with big responsibilities.
Yeah.
I mean, when you connect billions, hundreds of millions, even billions, obviously cybersecurity is a pivotal and important factor. The way that we approach it is every country is different. Every region is different. Every operator is different. And the approach that we have taken is basically architect, manage our system, where we leave all that completely to the operator, to the cellular operator. I mean, we do not go directly to the market. We don't have a retail arm. We go through partnership, through the MNO, through the operators. They spend hundreds of billions a year in R&D and other factors. Security is part of what they do. So our philosophy, we leave the management information, all the security aspects to the local operator. We enable the connectivity as a transparent medium for them to get access and to be able to connect every single region where they operate, but we leave all the management of their services and information to each of the operators. So we believe that should be the role. Another aspect of how we architect is that the data always stay in the country where the data is originated. There's no cross movement of information, and that's the way that we address it. Then you have also the aspect of the security of the spacecraft, so the asset that you have in space, which is that's obviously something that how you manage them, how you position them, and all of that we do ourselves.
But that data protection and usage is a very kind of topical, Maha, isn't it? I mean, in terms of how is it used? Where does it go?
You mean on the data side?
Yeah.
Yes. And here, I would really like to give you a perfect example. Cruise, right? So Cruise has been around for over 10 years. They raised billions of dollars. They tried to build autonomous robotaxis. They were certified 3 months ago to operate in the full California. I rode the car. It's very impressive. But just to tell you, they missed a very small use case, which is what if the pedestrian is laying on the ground, will the car be able to see it? In the dark at night? The answer is no. See? So data is very important as you aggregate. But at the end, how do you process the data and what do you do with the data? And is the data good enough for you to implement your application? So we are witnessing a paradigm shift between the convergence of connectivity and mobility. Why? Because our cell phones, as soon as we go inside our cars, the car become our cell phones. In the future, when we start to alleviate some of these congestions in the roads, you need mass movers. You need these autonomous shuttles to deliver the last mile or the last 10 miles, right? So people can actually be on their cell phone, be connected without driving the car. My daughter, she's a professor at Stanford. She never owned a car because for her freedom is being connected. So this convergence between connectivity and mobility is not going to happen until autonomous robotaxis, autonomous mass movers are going to be mainstream. It's going to take time.
When?
Well, in my prediction, when I started Metawave, it was 2017. Elon Musk was saying by 2019.
Okay.
Look, with 2023, and we're not there yet, right? But I would say in 5 years. Why? Because we passed the hype cycle. We're now at the growth stable stage. People learned. They created the data clues, learned their lesson. They missed that very use case. They got stripped from their certificate. But Waymo's not. So Waymo's still operating. That competition is going to be very helpful.
AI is in the hype. Pardon?
May I touch on one point
Yeah,
you made? Because I think you made a very important point. I'd just like to emphasize that. It is about the quality of the data which is going in there, right? Because the quality of the data in the end determines the outcome, right? You can never be better than the data quality you have in there. And we see this in different sectors. We see it in mobility. We will also see this in ESG, right? Right now with carbon credits, for example, which is going to be a fantastic tool. Right now it's not yet there. Where's the problem? The problem is that you're not really using data, you're using desktop models, you're trying to simulate, and then obviously these models are positively biased towards giving more output than actually realistically there, because then you have more carbon credits and so on and so forth, right? So again, we will going to see in ESG and mobility and other sectors a huge push towards really, really good data. So, and I think that's an opportunity, also opportunity for the market, opportunity for connectivity, opportunity for Earth observation, to provide the best possible data, to make the best decisions, and to train the best algorithms, then using machine learning to get these models going.
The US, correct me if I'm wrong, mandates now enforcing long-term sustainability issues. I mean, you mentioned there the carbon credits, Max. You know, where is this going in the near future?
Yeah, so if I might pick up here directly, we've seen that there's been, recently there's been press releases on some of the big carbon companies in the world, and not carbon emitting companies, but basically carbon validation, carbon credit companies. And there's been cases where they've been 400% over modeling of the actual carbon credits. So what you need to do is, you need to start measuring the actual truth. You need to start measuring, if you plant a tree, that is fine. You need to make sure that this tree doesn't die, because in the moment it dies, it will then give off all the carbon stored into the atmosphere again, right? So you need to look at this also from the sustainable point of view, and just planting trees is not going to be a solution. So what we're going to see is a shift, a paradigm shift from ESG modeling to ESG measurement and validation. And actually where we'll be coming in, because that's exactly what we're doing. But I think the shift is going to take another 3 to 5 years from now, but this is where we need to move. And again, it's the matter of trust, right? Same as with AI and other things. You need to trust in this data, you need to trust in this model, in the output, and you can only do this if you have good data.
Abel, you talked a little bit earlier about the vulnerabilities. When we look at potential risks to consider around space-based, that's hard to say, space-based networks and connectivity, like signal jamming, space debris, weaponization, how can the commercial sector work closely with governments to address this?
Yeah, I mean, that would regulator have a role in the traffic caps into what get to space. The challenge there is how they don't slow down progress and how they don't are in the middle of innovation and new services being rolled out into space. Space is large. Right now, in reality, if you have enough capital, you can launch into space, and then it's almost a self-regulated environment. So the way that I see it is companies that get access to space, they work hard in making sure that they can control the assets that they put in space, that they can dispose these assets safely back to Earth after the life is met. But my view, in general, is less regulation the better. However, there is a minimum regulation that is required in order to be able to coordinate the usage of the safe and responsible use of space. So I had you have multiple aspects of regulations that you need to think about. One is regulations required to get to space, the regulation to use a spectrum that comes from space, and then the actual coordination of frequencies and slots and orbits that also get done between multiple countries. I am a believer of less regulation the better, and also let the private sector to innovate and create, to sparkle the big opportunities that are coming and becoming reality with the use of space.
May I add a perspective here?
Of course.
So I agree in general, but I think there's a conflict here with regulation and with the speed we need to have. There are a couple of things which are now challenging us, climate change being one of the biggest things, and we don't have that much time to solve it, right? So, for example, climate change will manifest itself initially as water change. And it's funny that we're sitting in Saudi Arabia. Saudi Arabia has 0 rivers, at least no permanent rivers, has 2 lakes, has about 5 cubic kilometers of water, out of which most of it is used from underground aquifers, and is using a lot of energy to do desalination. You know how it is to live with little amount of water, right? That's going to be an example for nearly everybody in the world in a few years from now. To give you an idea, we are estimating that, or the FAO, the Food and Agriculture Organization of the United Nations, is estimating that between now and 2030, so that's 7 years, not even 7 years, water prices are going to increase on the global average by a factor of 6 to 12, propelling food prices by a factor of 4. Right? This means that a lot of people won't be able to afford food anymore in 7 years from now. 7 years. It's not 2050, it's not 2040, it's 7 years from now. So looking at this, we can't wait for all the regulations to come. At least on the European side, and I think I'm okay as I'm European, we are slow. We're slow with regulations. And here I think we need to take a bolder stance, because we have left the trajectory where we can do a bit better engineering every year, and then eventually arrive at the goal, be it the climate goal, be it something else. We have left that path. This path is not a solution anymore. We need to invest now, and I'm very happy to see that this conference is having this kind of spirit, this idea. We need to start investing into quantum leaps, into leap innovation. We need to take a daring move because our risk profile doesn't match the objectives anymore. And only by that way we can arrive at a trajectory where we can actually hold off some of the biggest challenges which are still ahead of us. So I think there's a problem with regulations being too slow at the moment, and we cannot always wait for them. So underlining basically what you've said, that less regulation is good, but sometimes we simply won't have the time because it's in conflict with the big challenges we're having.
Well, you've sort of encapsulated in that answer. We're drawing to our last few minutes, so I did want to ask you, what you think has been the biggest challenge to get to where we are today and where we are going to be in terms of connectivity 5 years from now. So we'll start with you, Max, because you're already holding the floor, and then we'll make our way towards me.
Sure. So I think what we need to do is we need to operationalize it. I think over the last years, there's been a massive progress in what we can do. And look at Starlink, for example, as one of the examples. And there's going to be more of these things coming, be it Iris Squared or being other things. So that's going to be a key component, and space in general, be Earth observation, be connectivity, is going to be a key component to tackle these challenges. However, now what you need to do, because we're still children in how to use that, we're still children in using AI, still children using this massive amount of data to understand the world, because the world, our understanding of the world will exponentially change in the next couple of years. We'll have a more granular, better picture of the world as ever before. And we need to prepare ourselves to actually handle that, or to use tools to handle that. So I'm an optimist. I think we can do it. We can pull it off. We just need to have the right spirit, and we need to be daring.
Abel?
Well, we on this journey to get where we are, I mean, we invented 5G connectivity from space. And for that, we had on this journey that had been 7 years to this point, we had invested over $1 billion, getting close to $1 billion of investment, 3,000 patent and patent pending claims. And we're now getting into what is operations, and which we starting with our launches starting as early as February, March next year. So it has been a journey of innovation, a journey of partnering with the operators, partnering with regulators, bringing a whole ecosystem of the largest cellular operators, wireless infrastructure companies to be part of a space. And that has been what we have been doing for the last 5-6 years, and that's what we're going to start changing very, very rapidly as we operationalize our system.
Thank you. Maha?
So I want to go down to basics. Climate change. Persia witnessed 154 Fahrenheit on the tarmac of an airport this summer. We know this number is going to just keep increasing. At this temperature, airplanes cannot take off, or if they take off, they have to reduce their payload by 50%. What is the impact on that business, on that industry? It's huge. The highest carbon footprint is coming from commercial industrial productions, from households, using air conditioning, from transportation. So something has to be done in those sectors. In general, I'm just saying, because this is not sustainable and the impact is huge. I was at the Sovereign Funds event in Dallas, and I was very happy to hear investors, these are family offices, these are endowment, these are hedge fund investors, talking about the impact of climate change on their investments. This is how far they think about it, right? So the investors now, they want to invest to make sure they protect their investment in all these various verticals.
Dr. Maha, Abel, and Max on the end, thank you so much for that wonderful conversation, and thank you, our audience, for being with us today.
Thank you.
You're very welcome.
Thank you.
Well done.
Good seeing you.
Yeah.